Hi, my name is Aravindan and I'm going to be teaching you guys chapter 7 of Form 5 Mathematics, that is measures of dispersion of grouped data. So as you can see here, these are some formulas that we'll be using throughout this chapter. So let's hop on to the first example. The data on the right shows the heights to the nearest of centimeter of a group of Form 5 pupils. So question A is asking us to determine the class intervals of for the data if the number of classes required is 6. So in order to find the class interval, we need to use this formula here, right here. So first we need to find the largest data value and the lowest data value from this group data here. So the largest one is 173 and the lowest data is 145. So then we go ahead and substitute those numbers into the formula. So it should be looking something like this. And then go ahead and calculate it. When we get 4.7, then we round it off and make it 5, and this would be our size of interval. So we're done with A, so let's go ahead and do B. So B is asking us to construct a frequency table based on the information in A. Hence, complete the frequency table with the lower limit, upper limit, midpoint, lower boundary and upper boundary. So since we know our size interval, I'm going to go ahead and construct our class. So I've gone ahead and construct the table and fill in the class and the frequency. So now let's go ahead and find the lower limit and upper limit. So the lower limit is this, and the upper limit is this for the first class, and then it goes for the rest of the class as well. So I'm going to go ahead and fill those up. So the first class would be 145, 150, 155, 160, 165, 170, and then the upper limit is 149, 154, 159, 164, 169 and 179. So after finding both the lower and upper limit, now we can find the midpoint. The midpoint, to find the midpoint, we need to plus both the upper limit and lower limit and then divide it by 2. So I'm going to go ahead and do for the first class right here. So 149 plus 145 divided by 2, and go ahead and calculate it. So I'm getting the answer 147. So I'm going to go ahead and fill the others up. So after finding the midpoint, we can find the lower boundary. So in order to find the lower boundary, we need to take the lower limit of the second class plus with the upper limit of the previous class, that is 149, and divide it by 2. So I'm going to show you right here. So I'm going to take 150 plus 149, then divide it by 2. And I'm going to go ahead and calculate it, and I'm getting the answer 149.5. So this is for the lower boundary for the second class. And I'm going to go ahead and fill up the others. So I've gone and done the rest. To find the first class lower boundary, so we just find the difference between this class and this class. So go ahead and take these values and divide minus each other. So then I'm getting the difference as 5. So then what we do, we take 149.5 minus 5. So I'm getting 144.5, and that is the lower boundary for the first class. So next, let's move on and find the upper boundary. To find the upper boundary, we are going to need the upper limit of the first class plus with the lower limit of the second class, then divide it by 2. So it should be looking something like this: 149 plus 150 divided by 2. Then we should be getting the answer 149.5. And the second one, so we're gonna take the upper limit of the second class plus with the lower limit of the third class. So it should be looking like this: 154 plus 155, then divide by 2. So I'm getting the answer 154.5. So I'm going to go ahead and fill up the others. So I've fill in the other values of the upper boundary. So this is how the table should be looking like. So next, let's go ahead and let's find out how to construct a cumulative frequency table. So I've gone ahead and draw the table and adding the classes and the frequency based on the diagram here given. So to find the cumulative frequency, we need to go ahead and first bring this 4 just right here like this, and then this number plus this number right here in order to get the cumulative frequency. So 4 plus 5 is 9, then 9 plus 8 is 17. Then we can go ahead and do the same thing with the others. So 7 plus 17 is 24. Then 24 plus 3 is 25. 24 plus 3 is 27. Alright. This is the cumulative frequency. So next is, let's look at how to construct a histogram and frequency polygon. So this is the step-by-step instruction on how to construct an histogram and a frequency polygon. You guys can go ahead and pause it and read it for yourself. Okay, then we can just jump on to example 3 and start constructing the table and doing the polygon the histogram and the frequency polygon. So I've gone ahead and construct the table, adding the classes and the frequency based on the given diagram here. So I'm going to go ahead and do the midpoint for the first class. So as usual, we're going to take the upper limit of the first class, the upper limit of the first class plus the lower limit of the first class, divide it by 2, and then go ahead and calculate it, and I'm getting 74.5. For the second class, it's 84.5. So you can roughly get a good look at this, and you should see a pattern. So this is from 74.5 to 84.5, so it's like 10. So we can just go ahead and just plus 10, 10, 10, 10. So we plus 10, so 94.5. So I've gone ahead and just fill up the rest by just adding 10, 10, and 10. So now we are supposed to find the lower boundary and the upper boundary. So again, to find the lower boundary, it's better we use the second class first. So I'm going to take the lower limit of the second class plus with the upper limit of the first class, then divide it by 2. So it should look something like this: plus 79 divided by 2. I'm getting 79.5. This is the second class lower boundary. For the third class, we're gonna take the lower limit of the third class, add it with the upper limit of the second class, then divide it by 2. So it should look like this: 90 plus 89, then divide by 2. So I'm getting the answer 89.5. So I'm going to just go ahead and fill up the rest. Okay, I've written down the other values of the lower boundary. So now it's time to find the upper boundary. So the same thing as previously we've done. So to find the upper boundary, we need to take the upper limit of the first class plus with the lower limit of the second class, then divide it by 2. So it should look like this. So we should be getting the answer 79.5. This is the first class upper boundary. So for the second one, we're going to do the same thing. We're going to take the upper limit of the second class plus with the lower limit of the second class divided by 2. So it should look like this. I'm getting 89.5. So I'm going to go ahead and fill up the rest. Okay, so now I'm going to be explaining the histogram and frequency polygon graph. So as you can see here, I've got a ready drawn graphs. So normally in the question, they will already provide you the scale for the horizontal axis and the vertical axis. For in this case, the scale for the horizontal axis is 2 cm to 10 km, and the vertical axis is 2 cm to 10 cars. As you can see here, the speed is 2 cm to 10 km. So for the horizontal axis, we just follow the lower boundary. Okay, as you can see, it starts from 69.5 and ends with 129.5. So it goes like this. Okay, starts from 69.5 and ends at 129.5. And then the height of the bar represents the frequency. So for the first class, 69.5, right? So the frequency is 5. So 5. And then we have 10, 20, 30, 25, and 10. So for the frequency polygon, we do not draw the bars, we only draw the straight lines. As you can see here, the lines touching in between the bars. So to find the value of it, we need to find using the midpoint. So we use the midpoint here. So the first one is 74.5, and then 84.5, 94.5, 104.5, 114.5, and 124.5. So in the frequency polygon, both ends must touch at the ground of the horizontal axis. That is the rule of constructing a frequency polygon. So next up we have distribution shapes of data. So we have 4 shapes right here. So the first shape is called bell shape, obviously because it looks like a bell, as you can see. Next we have uniform shaped. The third one we have is right skewed and left skewed. So the reason they call this as a right skewed is because the right hand side is more longer, as you can see here. So that is why it's called right skewed. So for the left, It's also called left because it's more longer on the left hand side. So let's look at the questions. So the question A, state the distribution shape of the histogram of two events. So we have two diagrams here, and they're asking us to write the distribution shape. So the first one obviously is the bell shaped, because as you can see it's going like this, so it's a bell shape. And the second one, it looks like the uniform shaped. So B is asking us which event has a wider dispersion of time taken, and give the reason. So as you can see here, obviously backstroke looks like it has taken the most time. So to confirm it, you can just take the midpoint of the the midpoint of the last class minus the midpoint of the first class, that is 102 minus 72 seconds, so 30 seconds. So let's move on to C. So C is asking us between backstroke and freestyle, in which event did the swimmers perform better? Obviously C, we know that freestyle is performed better. So that's all.
Good evening, and today I will be teaching chapter 7.2 from 4, measures of dispersion. So right here we have a table of student allowance. So let's us group the data together. So first is the allowance, right? And we have number of students, which is the frequency F. So from this table we can conclude that we have a range of numbers, so which is 0 to 9 and 10 to 19. So just like put the range on it, because the minimum is 5 and the maximum is 45. So I just put like this lah. Okay, so let's just go on. The next will be 20 to 29, 30 to 39, and 40 to 49. Number of students, so like 0 to 9 we got only 5 and 5, so it's 2. The frequency will be 2. Then 10 to 19, 10, 10, 15, so 3, right? This one already. Then 20 to 29, 20, 27, 25, 28, 29. So we got 5 frequency here. And then 30, 33, 35. So and 37. So we got 4. And the last one 45. So here we got 1. So next we need to find the midpoint, which is x. Midpoint x. So the midpoint will be for this row will be, how to find the midpoint. Midpoint is lowest and highest add together divided by 2. So 0 plus 9, which is 9, divided by 2 is 4.5. Then for the second row, that is 14.5, 24.5, 34.5, and 44.5. So first we'll want to find the range. So So range. We can know from this and this there is two range, because this is a range already, and this is just numbers. So for this range, it is the highest minus the lowest, which is 40. But we'll not see this again now. So we'll just use this table. Okay, so the range from this table is, we pick the midpoint of the highest class and the midpoint of the lowest class. So the midpoint of the highest class is 44.5 minus the lowest midpoint of lowest, which is 4.5. So we know the range is 40. Okay, so next is the interquartile range. So interquartile range, which also called IQR, there is only one formula to calculate interquartile range, which is Q3 minus Q1, meaning that quartile 3 minus quartile 1. So from how to know our total number, so we can find it at the frequency. So the total number of student is 2 plus 3 plus 5 plus 4 plus 1 is 15. So the total frequency is equals to 15. So quartile 3, the formula for quartile 3 is total divided by 3/4, multiplied by 3/4. So that means 15 multiplied by 3/4, and we get 11.25. Now for the quartile 1, also the same formula, but this time is multiplied by 1/4. So we get 15 times 1/4. So the answer will be 3.75. Okay, so Q3 minus Q1 equals to 11.25 minus 3.75 equals to 7.5. Okay, now let's go to the next thing, which is variance. So variance, the symbol is like this. Square. So this is the symbol for variance. So the variance formula is the total of x square divided by the total number of frequency minus minus the mean of the data square. So next, what we need to do is we need to find fx square. So how to find fx square? So first, every time we will do this fx. So fx means f times x. So you get 4.5 times 2 equals to 9. So the second row will be 14.5 times 3 equals to 43.5, and the list goes on. So the next one will be 122.5 and 138 and 44.5. So here this column will be the x square. So x square is just 4.5 square. So you will get 20.25, and the list goes on now. So I will write it out. So here will be 210 and 2.25, and the next one will be 600.25. Next one will be 1190.25, and the last one will be 1980.25. So we have this already, right? Now why I write this is for later use. For the fx, we'll use it later, and we write the x square is for us to find the fx square. So we'll write it out so we won't confuse. Okay, so in the last column we'll write the fx square. So fx square is just highlighter f times x square. Okay, so 2 times 20.25 we'll get 40.5. Then 3 times 210.25 we'll get 630.75, and I'll just write it out again. And this one will be 4,761, and the last one is 10,000. It will be 1,980.25. Okay, and every time you write the column with f, so for example this, right? So this, you have the total number of frequency is equals to 15. So here, so for every f, you need to write out the total number. So to have clearer, so you need to calculate the total number of x's. So 9 plus 43.5 plus 122.5 plus 138 plus 44.5 plus that, and you will get 357.5. and same for this also. Okay, it's the same color, sorry. No, it's not. Yeah, never mind. Give me a second. Okay, so for this, the total number of fx square is 10,913.75. Okay, so you write this out because it will like help you very greatly. So you can see, wait, I erase this. Okay, so we can see fx square, which is green in color, fx square, and this one is the total number of f frequency, and now we can calculate it. So the total number of fx square is, bracket first, 10,913.75 divided by 15. So the mean of the data square is actually fx, it's actually fx. So from this we can know that, highlight blue so you guys can see better. Okay, so that's why we do for this column, and this column. Yeah, so fx, the total number of fx is 357.5 and divide by 15. So we'll get what? We'll get 694.25 minus 23.8333 lah, 3333 never ends. So it will be 71 70.4167. So depends on the question, but usually they will ask for like 2 decimal places. So for 2 decimal places, the answer will be 670.42. So next is standard variation. So standard variation symbol is actually this, is the same as variance, but it doesn't have the square. So the formula for standard variation is square root, a bit chart. You use a ruler. Okay, better. So it's just the same formula as the variance, but you square root it. And just calculate it lah. But if you done the variance step, you can actually just use the variance number. So for example, here I put decimal place longer, so it will not it will be more accurate. So you square root it, and the answer will be 25.8924. So you 2 decimal places and you will get 25.89. So that's all, right? Next, we'll go to the how to draw a box plot. So box plot, I have a graph here, ogive here, and let's do the box plot lah. So the box plot, we will first find the quartile 1. So the maximum, the total number is 60. So quartile 1 equals to 60 times 1/4, which is 15. Quartile 2 is 60 times 1/2, which is 30. And quartile 3 will be 60 times 3/4, which is 45. Right? And minimum value, we can see that here is minimum value equals to 149.5, and the maximum is 449.5. Okay, now let us start drawing the box plot. Okay, I'll just use this better lah. So we'll start by the minimum and the maximum. Minimum is 149.5. So this one will be, I use 2 blocks lah. So actually the box plot, the range here, this one, this one, you can just copy this one if like it's just numbers lah. Okay, so I just copied it. 199.5, 249.5, 299.5, 349.5, 399.5, and the last one 499.5. Okay, now let us find the quartile 1, which is 15. So how to find 15? So actually you have to look at the cumulative frequency to find the 15, 30, and 45 for the quartile lah. Okay, so right here you can see it's 20, 40, and 60. So from here we can know that make it smaller, 15 is, so here is 10. So we can calculate like 2, 4, 6, 8, 10, right? So 15 is 2, 4, 6. So 4 and 6, the middle is 5. So 5. So here we have 15. So we'll just 15. So we'll just do like this, and nope, that is wrong. Nope. Yeah, so like this. So we can find out that how to find this value, oh shit, this value. So for us to find this value, we can use 299 point, why so big, 299.5 minus 249.5 and you calculate how many boxes have here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So you divide it by 10, you get like 50 divided by 10 equals to 5. So that means one box is 5. So 5, 10, 15 in the middle. 5 divided by 2 is 2.5. So we can know that for the quarter 1, 15, the duration is 249.5 plus 5 plus 5 plus 5 plus 2.5. So that means is 17.5. So the number is let me calculate that. The number is 267. So we'll just write here lah. 267. Alright. Now we going to find the number for 30. Okay. For the number of quartile 3, so 22, 24, 26, 28, 30. So 30 is on the line, so we can just find it. 299.5 plus 5 plus 5 plus 5. So 299.5 plus 15 equals to 314.5. The last one, 45. You can see that 42, 44, 46. So it's in the middle again. In the middle. Just note that this is the middle. I easy to redraw. So 5 and 2.5, so 7.5. So we don't need a ruler now. So 349.5 plus 7.5 equals to 349.5 plus 7.5 equals to 357. So we got the 3 quartiles already. So now we can draw the box plot. So the first number is 267. So 267 is right here. Okay, so this is 267, which is quartile 1. And quartile 1 lah. And 314.5. 314.5 is right here. Actually, just use a ruler. It's easier to use a ruler. So bring a ruler to class and exam, guys. 314.5. I just agak lah. And 357. So this is your Q1, Q2 and Q3. Alright. Okay. Now for the maximum value and the minimum value. Okay. So this is how you draw a box plot lah. Wait and this one is Q2 and Q3. So there you have it, a box plot. So from the box plot, you can actually know that the graph is actually symmetric distribution, or like left skew distribution or right skew distribution. So how to see like which distribution is what? So if the box plot is like right here, I use highlighter. If the box plot is more to the right, then it's left skew, because like skew is like this, right? So it is a left skew if the box plot this box is here, and if the box is more to the right, then it's left skew. It's right skew. More to the left, then right skew. more to the left, right skewed, more to the right, left skewed. So it's the opposite lah. Okay, but if it's in the middle like now, then it's symmetric distribution. Okay, so remember this, guys. The question will ask like what this graph is. So that's all for today, and thank you. Have a nice day.